Imagine you have a pet cat with brown eyes and white fur. If you plan to have one more cat of the same type, should it mate with a cat having the same traits? What if it mates with a partner having blue eyes and dark furs? Will the progeny get the desired traits? To study the inheritance of two independent or separate traits, dihybrid crosses are performed. In this video, we will be discussing the dihybrid cross performed by Mendel. So let's begin the journey together. A dihybrid cross involves parents with two contrasting characters to observe the inheritance of the gene governing the pair of the chosen characters. So let's discuss the dihybrid cross between a pure breeding pea plant that differs in seed color and shape as Mendel performed. Here, the alphabets capital Y and small y represents the alleles for yellow and green colored seeds, while the letters capital R and small r represents the alleles for round and wrinkled shaped seeds. So, the genotype of the pure breeding parent pea plant with yellow color and round shape is capital Y, capital Y, capital R, while that of the parent plant with green color and wrinkled seeds gives small YYRR. The parent pea plant with capital letters YYRR genotype forms all the gametes with capital YR alleles, while the parent plant with small letters YYRR forms all the gametes with small y and r alleles. Random fertilization of these gametes produce the F1 generation with the genotype capital Y small y and capital R small r. The phenotype of F1 progeny is yellow colored and round shaped seeds, as you can see in this diagram. So, what do you infer from this cross? The yellow color and the round shape are dominant over the green color. To obtain the F2 progeny, the F1 plants are self-fertilized. The F1 plants with genotype capital Y small y, capital R small r produces 4 types of gametes in equal proportions. These are capital Y, capital R, capital Y small r, small y, capital R, small y and small r. This cross can be represented using a Punnett square. So, what is a Punnett square? It is a diagrammatic representation which helps in the prediction of genotypes. Random fusion of these gametes produce the F2 generation in a 9:3:3:1 ratio, wherein 9 out of 16 F2 plants are yellow and round seeds. 3 out of 16 are green round seeds. Another 3 out of 16 are yellow wrinkled seeds, and 1 out of 16 is green wrinkled seed, and 1 out of 16 is green wrinkled seed. So, let us find out that the F2 phenotypic ratio for the dihybrid cross is thus 9 yellow round is to 3 green round is to 3 yellow wrinkled is to 1 green wrinkled. The genotypic ratio for the given cross is 1 capital Y, capital Y, capital R is to 2 capital Y, capital R, small r is to 2 capital Y, small y, capital R is to 4 capital Y, small y, capital R, small r is to 1 capital Y, small r is to 2 capital Y, small r is to 1 small y, capital R is to 2 small y, capital R, small r is to 1 small y, small r. Now that you know about the dihybrid cross, so can you tell the importance of the result of this cross? Which law of inheritance is proposed by Mendel is based on the result of the dihybrid cross? Think for a moment. Now, let's summarize what we have learned.
Manorama Horizon. Learning made simple.